Okay, let's talk about the translation of subclass from the ER diagram into relations. In this page, we show you with the example. We have an entity which is called employees. For the employee, it has three attributes: SSN, name, and not. The key is SSN. And for the employee in complex, it can be divided into some subcategories. Now, for the employee, we can have hourly employees. And for the hourly employee, it has two more attributes. The first one is hourly wage. The pay per hour for the employees, as well as hours worked by the employee. It is a subclass of the employees. We can see this, right? Besides the hourly employee, we also have this contract employee, right? It is also a type of employees in the complex. And for the contract employee, its attribute is the contract ID. We know that they are all the subclass of the employees, right? So when we do the translation of such ER diagram into relations, how can we do the translation? It will be very different, right? And before we show you the translation, we have a question ask you, right? So the first one is about the overlap constraint. So given a person like Joe, right? Can Joe be both a hourly employee as well as a contract employee? Yes or no? We know that these two employees seems to have no overlap, right? Because they are two different employee categories. A person cannot be both the hourly employee as well as the contract employee, right? Therefore, the answer to this question is no, right? It's disallowed. And then we come to the covering constraint. Does every employee entity should belong to either a hourly employee or a contract employee? The answer is yes, right? Because given an employee should be either a hourly employee or contract employee, right? Unless we have some other categories, we can add one more here, but it should belong to one of these subclasses, right? Therefore, the answer is yes. Every employee should have to be a hourly employee or a contract employee. Okay, so understand these two constraints, then we can do the translation. So given the diagram like this we show in the previous page, we can do the translation by translating these three entities, right? This is A doesn't require us to do the translation. Is A can help the translation of the entities we show at the bottom of the subclasses. I can show you the translation of these entities for you first, and then we'll come back to the slides. So we know that the first entity we can create is called employees, right? And we can borrow the relation we create before do the translation, right? The first relation we can create after the translation is called employees. It has three attributes. SSN is its key, right? Besides these employees, we also need to do the translation of the hourly employee as well, right? And then we can create another relation. It will be hourly employees. What are the attributes inside it? So we have hourly wage, right? Hourly wages, it will be real. We have hours worked, it will be int, right? Then the question will be, what will be the key for the hourly employees? We know the hourly employee is a subclass of the employees. We have to borrow the SSN, this is the key of the employees, into our employee as well to show that the key, right? Because it is a subclass. It is also employee, right? So therefore, for the employee, we have to borrow the SSN as a key for the hourly employee. And when we create a table for it, we have also to mention this SSN is a foreign key, right? A foreign key reference to the employees is table. It's our employees. Besides this, we also have the contract employee, right? We have to borrow the SSN from the employees table, and as a key, as attribute inside the contract employee, we also have the contract ID, right? it is a VRCHAR, for example, not 10, for instance. And we borrow SSN as the attribute of both our employee as well as the contract employee. At the same time, they are all the keys for the hourly employee and the contract employee, right? Yeah, so this is the way we do the translation for the subclass. For the hourly employee, we have to borrow the SSN from its subclass into its relation as the attribute as well as a key. And for the contract employee, it's similar. We have to borrow SSN into it as a key attribute inside the new relation we create. This is the way we do the translation for the ER diagram in two relations based on what they will cover in the ER model, right? If you still remember in the ER model, we show you an example, right? How do we store the data for subclass? We also compare against the programming language about class inheritance, right? I hope you still remember, and you can also go back to the slides in the previous lectures to see how we introduce that part before. This is one way we can do the translation, right? In this translation, we can also show you how can we store the data, right? Based on the translation in this way, we can store the data into 3 tables, right? And I can show you, like we can have an employees table like this. Let's assume we have an employees table. As shown here, we have 3 employees. And based on the employees table, we can store some information into either the hourly employees or the contract employees. Let's assume we have the hourly employees table as well. Inside this employee table, we have 2 other attributes. The second one will be the hourly wage as well as the hours worked. Let's assume among these 3 employees, John is the hourly employee, and then we can delete these 2 rows. Hourly wage, for example, we can say the hourly wage is $8.01 per hour. The hour works like 8 hours per day, for example. This is for the hourly employee for John, right? Besides this hourly employee, we can also have this contract employee, and we can show, maybe you can copy this table instead, right? So we have the contract employees. Besides SSN, it has a contract ID and its attribute. Okay, we can delete this column instead. We know that John is the hourly employee. We can delete it. It cannot be he cannot be both our employee and a contract employee, right? Therefore, the contract employees will cover both Jimmy and Lucy. Let's assume its contract ID is 00000 and 1. Right. And the contract ID for Lucy will be, we change this one to 2, right? Given an employee, he or she cannot be both our employee and a contract employee. In other words, this 2 table has no overlap, we showed before, right? And also given an employee, it will belong to either our employee and a contract employee. It will cover all the employees, right? So this is one way we can do the translation. We can also name this translation rule as ER model-based translation or ER approach. So as shown here, the first approach we can use is called general approach or the ER approach. We can create 3 relations: employees, hourly employees, contract employees. For the hourly employees, it covers both the information attribute of itself as well as the keys borrowed from the employees. This is a subclass, right here. It will be very similar for the contract employee. We cover SSN as well as its contract ID as attributes, right? So here we need to pay attention. If we delete an employee in the employees table, then the corresponding hourly employee must also be deleted at the same time. In other words, for the hourly employee inside this relation, if we create tables for it, this SSN should be a foreign key referring to the employees table, right? And at the end, we also need to mention on delete cascade we showed before, right? To maintain, when we refer to the employees, it must exist. If we translate in this way, it will create some problem for us, because if we do queries about this our employee, and we try to get all the information for the employees, then we have to combine the employees table with our employee table, so we can get the complete information, right? In other words, it may require a join of two tables to get the sum attributes. This join is an operator we will show later. It combines two tables together in the query process. So this is one way to do translation. Actually, we also provide you with another approach. It is called the OO approach. This one is very similar to the object-oriented programming we learned before, right? For the object-oriented programming, we know that for each class, all the attributes will be stored in one storage space, and all the information will be in one storage space, right? And we can also borrow idea from the object-oriented programming as well to the translation, and we create this OO approach as shown here. So for the OO approach, what does this mean? Before we do the translation as shown here, this is one way to do the translation. We translate everything into three relations. So the OO approach to the translation in a very different way. It translates everything into two relations. The first one is our employee, the second one is the contract employee. Let me show you how to do the translation this way. I can add one line to divide them. So the first one is the ER approach, right? Okay, I can highlight this one. So this is one way to the translation based on ER approach. This one works for you, and it works very well, right? Besides this one, we can also do the translation of subclass in another way. It is called the OO approach. So in both the homework and exams, we may have some questions on this, on both the ER approach and OO approach. If we translate in the OO approach, how can we do the translation? In the OO approach, every information will be in one class or in one relation, right? In other words, for our employee, the attributes will cover the SSN as well as the name and not information. So in other words, we have to add this name and not into this relation as well. Then we can create this our employee relation. In this relation, it covers all the information for the employees, SSN, name, and not, as well as its special attributes, hourly wage, and hours worked. Every information will be in this relation. It will be similar for the contract employee, right? Inside, we have to add this contract ID as one more attribute to be inserted into this new relation, right? There should be a comma here. Right. You can compare these two different translation approaches. In the first one, we translate into three relations. So when we do the queries based on this translation among these tables, for example, if we want to get the employees whose contract ID is 1 and what's the name of the employee, if so, we have to get the SSN of the employee first based on contract ID, right? And then further refer to this table, get the name of the person, right? In other words, if we do the query based on the first translation, we have to combine this table with this table in queries. It is called a join. However, if we do the translation in the OO approach, then every information will be in one single table, right? It can provide us with some convenience in queries. So it is another way to do translation. Both of these two approaches will work for us. And this translation also has some problems, right? Because in this translation, we don't have the relations, we don't have the employees relation anymore. And it is based on the assumption that all the employees will be either the hourly employee or contract employee. However, if in some cases we have some employees who doesn't belong to the hourly employee or contract employee, then we cannot store this information for such employees anymore based on this translation rules, right? Therefore, you can see the difference between these two approaches as well as the advantages and disadvantages of them in either queries as well as in the data storage. You can decide which rule to use depending on your application. If your application ensures some constraints, you can either use the O approach or the E approach, and you need to discuss with the teammates very carefully, right? Okay, so this is about the approaches we can use to do the translation for the subclass.